Hello everyone! We, the Group 4 presenters, would like to greet you a blessed morning if you're watching this on morning time, or a blessed afternoon if you're watching this on an afternoon. Before we start, we would like to share the objectives of our video discussion for today. This is our final project in mathematics in the modern world. Our topic is all about the measures of relative position, so these are our objectives. Objectives: to learn the meaning of Z-score and percentile and how to compute each one. To learn the meaning of the 3 quartiles associated to a data set and how to compute them. To learn the meaning of box and whisker plot and how to construct a box plot.
First to discuss is the Z-score. What is Z-score? Z-score, or the standard score, measures the distance between an observation and the mean. The unit of measure of the Z-score is in standard deviations. Also, the Z-score for a given data value of x is the number of standard deviations that x is above or below the mean of the data. So there are formulas on how to calculate the Z-score. In calculating the Z-score for a data value of x in a population, we have Z sub x equals x minus mu over sigma. And in calculating the Z-score for a data value of x in a sample, we have Z sub x equals x minus mean over s. Remember, if the Z-score is positive, the positive score is above the mean. If the Z-score is 0, the Z-score is the same as the mean. If the Z-score is negative, the score is below the mean.
Okay, let's solve. John takes a standardized test. He scores a 65. The test is designed so that the population parameters are mean is 50 and standard deviation was 10. Maria takes a different standardized test. She scores a 29. The test is designed so that the population parameters are mean is 20 and the standard deviation was 5. Which student has the better test score? Using the formula of population, Z sub x is equal to the score minus mean over standard deviation. So, Z sub 65 is equal to 65 minus 50 over 10 is equal to 1.5. That is the test score of John. Next is the test score of Maria. Z sub 29 is equal to 29 minus 20 over 5 is equal to 1.8. Okay, that is the test score of Maria. John scored 1.5 standard deviation above the mean on the standardized test, and Maria scored 1.8 standard deviation above the mean on the standardized test. These Z-scores indicate that Maria did better than John on the standardized test. Next problem. Raul has taken 2 tests in his chemistry class. He scored 72 in the first test, for which the mean of all scores was 65 and the standard deviation was 8. He received a 60 on the second test, for which the mean of all scores was 45 and the standard deviation was 12. In comparison to the other students, did Raul do better in the first test or the second test? Okay, using the formula of sample standard score, Z sub x is equal to x minus the mean over standard score. So, Z sub 72 is equal to 72 minus 65 over 8. Therefore, z sub 72 is equal to 0.875. That is the first test. Then the second test is 60 minus 45 over 12 is equal to 1.25. So that is the second test. Raul scored 0.875 standard deviation above the mean on the first test and 1.25 standard deviation above the mean on the second test. These z-scores indicate that in comparison to his classmates, Raul scored better in the second test than he did on the first test. Next problem. A consumer group tested a sample of 150 light bulbs. He found that the mean life expectancy of the bulbs was 865 with a standard deviation of 85. One particular light bulb from the Durabright company has a z-score of 1.4. What was the lifespan of this light bulb? Okay, we're going to solve for x. So the standard score is 1.4, the mean is 865, the standard deviation is 85. So using the formula of the standard score, we can solve the x. So the standard score is 1.4 is equal to x minus 865 over 85. 119 is equal to x minus 865. Therefore, the x is 984.
So next to be tackled is about the percentiles. So what is a percentile? A percentiles are used to express the position of a certain value with respect to other values in a data set arranged by rank. Most standardized examinations provide scores in terms of percentiles, which are defined as follows. A value is called the PTH percentile of a data set provided P% of the data values are less than X. So remember, the median of a set of scores corresponds to the 50th percentile since the median is the middle point and therefore the point below which are 50% of the scores.
So, since my groupmate already discussed the concept of percentile, so now we will be moving forward in solving some problems that are related to percentile. So here, our first problem. In a recent year, the median annual salary for a physical therapist was $74,480. So if the 90th percentile for the annual salary of a physical therapist was $105,900, find the percent of physical therapists whose annual salary was A, more than $74,480, B, less than $105,900, then C, between the $74,480 and the $105,900. Then next, so by definition, so according to the concept, place of the percentile is also the value of the percent. So here the answer is by definition, the median is the 50th percentile. Therefore, 50% of the physical therapist earned more than $74,480 per year. So because it was stated in the problem that $74,480 US dollar is the 50th percentile, then the fifth or the place of the percentile is also equivalent or equal to the percentage. Okay, so next, because 105,900 US dollar is the 90th percentile, it was also mentioned in the problem that the 90th percentile is of the salary is 105,900 US dollar. Just the same at the first problem, it was discussed in the percentile concept that the place of a percentile is also an equal or equivalent to the percentage. Since it was 90th percentile, so it will be 90% of all the physical therapists made less than 105,900. Then the last ask in the problem was how many percent was earned between the 74,480 US dollar and 105,900 US dollar. So in finding that, we will gonna be subtracting the 50th percentile into the 90th percentile, so that we will gonna be finding out the median or between the 74,480 and 105,900. So the percent, so the in between them. So it will gonna be, so we will gonna be subtracting 90% minus 50% is equal to 40. So 40% of the physical therapist earned between 74,480 US dollar and 105,900 US dollar. So next, so moving on to the next problem. So here is a given formula. So it is a formula in finding out a percentile for a given data value. So there will be a given data, so we will going to be using this formula. This formula is the percentile of score x is equal to the number of data value less than x divided by the total number of data values times 100. So here is another problem. On an examination given to 8,900 students, Melly's score of 505 was higher than the scores of 4,255 of the students who took the examination. So what is the percentile for Melly's score? So you're gonna be finding out which place is, or in what rank in her score of 505. So here, so we will gonna be finding out the given data. So the number of data value less than x is what? It is the 4,255 of the students. So gonna be the number of data values less than x. And our total number of data values is the 8,900 because it is the overall total of the participants in the examination, which is 8,900. Then we're gonna be multiplying it to 100. 4,255 divided by 8,900 is 25 divided by 8,900 is 0.4780898887. Then we will gonna be multiplying it by 100. So the answer is 47.80, 89, 88, and 76. So to make it short, we're gonna be rounding it. So 47.88. So since it is 808, we will gonna be rounding the 0 into 1. So it will gonna be 47.81%. So it will be 48. So it is the percentile of score x. So Melly's score of 505 placed her at the 48th percentile. So therefore, Melly is at the 48th place in the 8,900 students.
Good day everyone, I will be discussing the concept of quartiles. I am Jala and Pete. Quartiles is three numbers Q1, Q2, and Q3 that are ranked dataset into four approximately. Each group are called quartiles of the data. In a more simple definition, quartiles is a divided ordered data set into four equal parts. So we can see here, we have Q1, Q2, Q3. Let's assume that this is a data and divide the data into four equal parts. There will be three quartiles formed, Q1, Q2, and Q3. And each part contains 25% of the data. Q1, as you can see, it has 25% of the set of data who has less than the value of Q1, and it has 75% of data who has the greater value of the Q1. Q2, which is also called the median, who has 50% less than the value of Q2 and has 50% greater than the value of Q2. And Q3, as you can see, we have 25% greater than Q3 and has 75% less than Q3. There's an example where the set data below shows the value Q1 equals 11, Q2 equals 29, Q3 equals 24 are the quartiles of the data. It is already a rank data and it's divided into 4. 1, 2, 3, 4. And you have Q1, Q2, and Q3. Next. These are the points to remember. Q1 is called the first quartile, Q2 is called the second quartile or the median of the data, and Q3 is called the third quartile. These are the median procedure for finding quartiles. Step 1, we should rank first the data. To find the median of the data, this is the second quartile. And third, but not the last, the first quartile or the Q1 is the median of the data value less than Q2. The third quartile is the median of the data values greater than Q2, which I was been discussed lately.
For this time, we'll be going to solve a problem. Are you ready to solve? Okay, let's solve it. The following table lists the calories per 100 milliliters of 25 popular sodas. Find the quartiles for the data. So inside this rectangle, this is the list of the calories per 100 milliliters of 25 popular sodas. Do you remember the step on finding quartiles of the data? So step 1 is rank the data from least to greatest. So as you can see, from 26 to 73. Next step is find the median of the data. Median is the middle value of the data. So the median of this data is 43 in rank 13. The median of these 25 data values has a rank of 13. Thus, the median is 43. The second quartile is the median of the data. So, Q sub 2 equals 43. Next step is find the first quartile and third quartile. The first quartile is the mean of the data values with rank 6 and 7. So in rank 6, the value is 39. In rank 7 also is 39. So 39 plus 39 equals 78. Then divided by 2
equals 39. So 39 is the value of first quartile. So next is the third quartile. Is the mean of the data values with rank 19 and 20. So in 19, there are 50 and 20, 53. So 50 plus 53 equals 103. Divided by 2 equals 51.5. So 51.5 is the value of the third quartile. So that's it. I hope you understand this topic about quartiles.
So are you still with us? So for our next concept is the box and whisker plots. So what is box and whisker plots? A box and whisker plot, or can be called box plot, is used to provide a visual summary of the set of data. It has 5 keys of the data set. There are the median, the first and third quartiles, and the minimum and the maximum values of the data set. So here is an example of box and whisker plot, and presenting here is the median, the lower quartile or the first quartile, the upper quartile or the third quartile, the lowest value in the dataset or the minimum, the highest value in the dataset or the maximum. So how do we construct our own box plot? Number 1, we draw a horizontal scale that extends from the minimum data value to the maximum data value. For example, you have a minimum data of 42 and a maximum data of 80. So we draw a horizontal scale by 5, so 40, 45, 50 until we reach at 80. Number 2, above the scale, draw a rectangle box with its left side at the first quartile and the right side at the third quartile. Please be noted, when drawing your rectangle box, make sure to align it to the value of your first and third quartiles. Number 3, draw a vertical line segment across the rectangle at the median or second quartile. So again, when drawing a vertical line segment, make sure to align it to the value of your median or second quartile. Number 4, draw a horizontal line segment called whisker that extend from the first quartile to the minimum, and another whisker that extend from the third quartile to the maximum. So please be noted, when drawing your whiskers, start with the rectangle box and extend it to the value of your minimum and maximum values. Next, who do you think create this box and whisker plot? So his name is John W. Tukey or John Wilder Tukey. He was born in 1915 and he died in 2000. So he was the person who invented this box and whisker plot. So John made many important contributions to the field of statistics during his career at Princeton University and Bell Labs. So John invented this box plot when he was working on his exploratory data analysis. So next is we will try to construct our own box plot, but please be minded, if your 5 keys of data are not given or present, then we will have to solve or determine the value of each data. This was tackled or discussed by the previous reporters on how to get the first and third quartiles and the median. So we need to apply the steps they give in order for us to construct our own box plot. So let's proceed. The number of rooms occupied in a resort during the 18 days period. So here are the datas: 86, 77, 58, 45, 92, 96, 83, 76, 75, 65, 68, 72, 78, 85, 87, 92, 55, and 61. So for our next step is we need to rank them from lowest to highest in order for us to determine the minimum and the maximum data values, and we can easily get or determine the median and the first and third quartiles. So here is the ranking. First is 45, second 55, followed by 58, 61, 65, 68, 72, 75, 76, 77, 78, 83, 85, 86, 87, 92, 94, and 96. So take down notes that minimum value is the first rank and the maximum value is the last rank. So the value of our minimum is 45 and the value of our maximum is 96. So let's proceed to step 2. So for step 2 is we need to find the median or the second quartile. So our median is rank 9 and 10. So we need to add 76 plus 77 and divide by 2. The result is 76.5. So next, step 3 is we need to find the first and third quartiles. So first, we need to find the first quartile. So the first quartile is the median of the data value less than the second quartile. So looking at the ranking, we have rank 9 and 10 for our median. So our first quartile is in the rank 1, 2, 3, 4, 5, 6, 7, 8, 9. So look closely from the ranking 1 to 9 and we see that the rank 5 is in the middle. So the value of our first quartile is 65. So next is we need to find the third quartile. So the third quartile is the median of the data value greater than the second quartile. We see that from rank 10 to 18, rank 14 is in the middle. So the value of our third quartile is 86. So we have now the complete value of our 5 keys of dataset. So again, the minimum value is 45. The maximum value is 96. The median is 76.5. The first quartile is 65. The third quartile is 86. So let's try to construct them into a box plot. So let's proceed. So what's the first thing we need to do is we draw the horizontal scale, then the rectangle box, then the vertical line segment, then the 2 whisker, the right and left whiskers. So this is the form of our box plot. So we draw a horizontal line segment, start by 5, so 40, 45, 50, and we stop at 100 because the value of our maximum is 96 and the value of our minimum is 45. So now, then we draw the rectangle box between the value of 65 and 86 because the value of our first quartile is 65 and the value of our third quartile is 86. Then we draw the vertical line segment, align it to the value of our median. Next is the 2 whisker. So the left whisker, we start from the rectangle box and extend it to the 45 value because the value of our minimum is 45. Then to the right whisker, we start from the box and extend it to the value of 96 because the value of our maximum is 96. Next, we're going to label them according to their values. So this is 45. So this is 96. So the first quartile is 65. The second quartile is 76.5. So the third quartile is 86. So this is the complete form or structure of our box plot. So next, remember, there are some advantages when doing this box plot. So box plot can easily estimate the quartiles of the data, the range of the data, and the position of the middle half of the data as shown by the length of the box.
That's all for our video discussion, and I hope you learned something from us. And also to those who have answered the surprise questions, kindly send your answers to our group chat so that we can check your answers. And that's all. Thank you for listening.